right, everyone. This lesson tutorial here is for lesson 2.7 for everyone who's been absent this week, which is a lot of people who've been out. So in case you missed this lesson 2.7, we're having our last quiz in the marking period on this lesson and this lesson alone. So this video is to help walk you through how to do and how to solve absolute value inequalities. So we've already done absolute value. If you remember, absolute value looks something like this, and there's always two scenarios here. You have two correct answers typically for an absolute value problem. You could have the absolute value of x equal to 3, or you could have x equaling -3, because on a number line, the absolute value represents distance away from 0. So you could be 3 units away to the right, but you could also be 3 units away from 0 to the left. So there's two scenarios that you need to account for in dealing with absolute value, because absolute value represents a distance, and distance could be either to the right or to the left of 0. So now this lesson, it's no longer absolute value equations, but we're going to have absolute value inequalities, so less thans and greater thans. So suppose I wrote these two absolute value inequalities. Absolute value of x is less than 3, or absolute value of x is greater than 3. What this means is we want to know, we'll do this one first. We'll do this one first right here. We'll get this one, we'll put this one up here. So we want to know how many numbers, or we want to find all the solutions that are less than 3 units away from 0 on the number line. So here's 0, here's 3, here's -3. We want to know, this is in the way. Hold on, let me move this. We want to know all the numbers that are less than, that's a less than symbol, right? Less than 3 units away from 0. If you just think about that really quickly, it's like numbers like 2, 1, 1.5, right? All these numbers in here are less than 3 units away from 0. That should be an open circle. But then we also have all these numbers over here. They're less than 3 units away as well. Like -2, -1, -0.5. They're all less than 3 units away from 0. Now this should look familiar to you. This kind of graph is an AND graph. Right? That's an AND. So when we have a less than symbol, it's an AND graph inequality. Okay? And that's what this says in this box right here. A less than symbol is an AND graph. And then we have the other scenario that I wrote up here. What would happen if we had x greater than 3? Absolute value of x is greater than 3. So this is us searching for all the numbers and all the solutions that are more than 3 units away. More than or greater than 3 units away from 0. That's numbers like 4, 5, 6, 7, 100,000, a million, a billion. Every number that's bigger than 3, basically. All these numbers out here, up until infinity, are more than 3 units away from 0. Right? And then we could also go the other direction. We have all these numbers to the left of -3 that are more than 3 units away. So we have what looks like an OR graph here. If you remember from last lesson, the ORs and ANDs, right? That's an OR graph. So if we have a greater than symbol, we have an OR graph. So following helpful hint could help you remember when it's an AND and when it's an OR. So if you have a less than, it's an AND, which the hint is less than. If you have a greater than symbol, it's an OR, and the hint is greater. Less than, greater. Okay? So you guys could try those two on your own. This one will be an OR. This one will be an AND. Let's do some harder ones where we could solve. So what we need to do here is we want to figure out which values of x are more than 7 units away from 0 on the number line. So what we need is we need two cases. Whenever we're solving one of these, we write case 1 to the left and case 2 to the right, okay? And what you do is, case 1, we're just solving for all the ones that are greater than 7. Okay, so you just basically rewrite your inequality statement without the absolute value bars. But then for case 2, we want to find the other side of the number line. We want to find all the values that are less than -7. Okay, so for case 2, we flip the symbol and change the sign. Because remember, if we're looking for all numbers that are more than 7 units away, well, we have all these numbers out here, right? That's case 1, right? All the numbers to the right of 7. That's what we wrote for case 1, all the numbers that are bigger than or equal to 7. But then we also have all the numbers that are less than -7. We have all the numbers that we have to account for this way. That's case 2. All the ones that are less than -7. That's why we wrote less than -7 right here. So we have to solve for both. We have to solve for both solution sets, the ones to the right of +7 and the ones to the left of -7. So then you would just go through and solve like you normally do. So x is going to be bigger than 12, or, because it's a gray tour, solve, x is going to be less than or equal to -2. And that's your answer. Then you would graph that on the number line down here. So bigger than 12 is going to be all these numbers, closed circle going to the right. And then less than -2 is going to be a closed circle going to the left. All right, so here's all the steps to solving an absolute value inequality. Actually, there's a step that's missing. First thing we always need to do is isolate. That's always the first step with absolute value. You got to isolate the bars. That should be called step 0. Isolate the bars, then decide if it's an and or an or. Then you set up your two cases. Then you solve each case and graph it. All right, let's do, let's see, let's try one more. I'll try to find the, yeah, so this one, example 5. We're going to add 8 first. We got to isolate the bars first. Before we could split it up into two cases, we got to isolate the bars. Then divide by 2, divide by 2. So we get, I'll write it down here, 4x minus 6 less than or equal to 10. Now the bars are isolated, okay? Now we could split up into two cases. So first case, we write our inequality less than or equal to 10. And then second case, we want all the ones that are greater than or equal to -10. Okay? And then you solve each one. We're going to add 6. 4x is less than or equal to 16. Divide by 4. Divide by 4. Get x is less than or equal to 4. Add 6. Here. 4x greater than or equal to -4. Divide by 4. Divide by 4. X greater than or equal to -1. So these two answers make up our solution set. So we also need to think about, okay, is this an and or an or? Well, that symbol right there is a less than, which means it's an and. Less than. See the and in less than? So we're going to graph this as an and. We're going to put a closed circle at 4. We're going to put a closed circle at -1. And we're going to graph in between. That's an and. Last slide and last thing here. Sometimes we get special cases. Remember, our no solution is one special case, and then infinite solutions or all real numbers is our other special case. That happens here with absolute value inequalities as well. Absolute value represents a distance. So if we add 4 to each side, right? And then we divide by -3. we're going to have to flip the symbol. I'll write it over here. Flip the symbol because we divide it by a negative. So now we have absolute value of 4x minus 5 is less than negative 3. So we know that anything in absolute value bars, so this thing is in absolute value bars, will eventually turn positive. So if we pick any number for x, whatever number we pick for x, at the end of simplifying this, the absolute value will turn it positive, right? That's always the case. It's always true of absolute value. Absolute value is always positive. So if we ever get a negative number over here, then we're going to get a special case. Because if absolute value is always positive, how could it ever be less than a negative? It can't. It cannot. So this is no solution. If absolute value is always going to wind up being positive, it can never be less than a negative 3. So that means this is no solution. There's no x value that will ever make this true, because it can't ever be less than a negative because it's always positive. And then the other special case is what if now we divide by negative 3, we have x minus 2. Now we got to flip the symbol because we divide by a negative. All right, flip symbol. Now if absolute value is always positive, right, like we just recognized in the previous one, then it will always be greater than a negative. Oh, that is always true. So when we get something that's always true, infinite solutions. All right, everyone, that's the lesson. Hope this video was helpful, and I'll see you in class. Bye.